Hi friends, today I'm going to teach units and measurement, which is the first chapter of physics. And this chapter is actually important because it will help you for the next chapters. And this is like the basic chapter. Okay, so today I'm going to teach the whole chapter in the NCRT using this NCRT book. And the thing is that if NCRT is really important for every entrance exams and also for the boards also it's important. And the thing is that if anybody can't understand this NCRT, the languages, anything, so I think you will not face such problems because I'm here. So today I'm going to teach this completely line by line, and also if there will be any problems which I need to explain those things, I'll also use my notes to explain you these things. Okay, and that's the thing. And we will also solve problems. So keeping these in mind, let's start this. Okay, so the first thing is an introduction. So what's written, actually introduction is also important in this because there are some lines which is important. That is measurement of any physical quantity involves comparison with a certain basic arbitrarily chosen internationally accepted reference standard called unit. So here we can note point that what is a unit. So this is the internationally accepted. It is also the reference standard which are known as unit. Okay, that's the thing. The result of the measurement of a physical quantity is expressed by a number of numerical measure accompanied by a unit. Although the number of physical quantities appears to be very large, we need only a limited number of units for expressing all the physical quantities since they are interrelated. Okay, this is the next point which is important because all the units are interrelated, and for the reason we need a limited units, not a lot we just need a limited. So the units for the fundamental or the base quantities are called fundamental or base units. This is one thing. And the units of all other physical quantities can be expressed as combination of base units. Such units obtained for the derived quantities are called derived units. So these are these is derived quantities, and this is fundamental or base units. And if we'll combine these both, it is known as system of units. That's it. Now I'll explain such something here in the notes. Okay, the first thing is that what is a physical quantity. The physical quantity, that is important. So physical quantity, the quantity which can be measured. Okay, physical quantity is what? The quantity which can be measured is known as physical quantity. So we have a formula, that is magnitude into unit. Okay, so I think you might be knowing this thing, that what is a magnitude. Magnitude is nothing but it's just the numbers, okay, the numerical values. And unit is something like kilometers, meters, seconds, these grams, these all are units. Okay, so suppose someone is telling that 500 kilometers or something like that, that is what, this 500 is the magnitude and the unit is kilometer. That's the thing. So physical quantity equals magnitude into unit. That's the thing. Next is that one thing, another formula is also there. Okay, next formula is that n1 u1 equal to n2 u2, and this is equal to constant. That's it. Okay, that's the procedure. Okay, so n1 u1 equals to n2 u2. So our a number of but it should be same thing. Like what is that? Like kilometer, meter, like that. Okay, so I will explain you this later because some examples can come and I will explain this thing now. But remember this formula. Okay, this is another formula which is there. And another thing which I need to write is that question can come also like this, that n is actually inversely proportional to u. Okay, so this numerical value is inversely proportional to the unit, to its unit. So we can tell that larger the unit, smaller the magnitude. Okay, so larger the unit, smaller the magnitude. Okay, this is the thing. How I can also explain this thing by giving an example, that suppose there is 5000 meters. Okay, this is 5000 meters. So here this numerical value is high, and this meter, this is low. Okay, because kilometer is greater than that, and so we can convert it into 5 kilometers. That's the thing. Oh, it's on walking. Yeah, so 5 kilometers we can convert it into 5 kilometers, and this kilometer value is great, and this 5 now it has low. So this is the thing, that it is inversely connected, that numerical value is inversely connected with this units. Okay, that's the thing. So it's very important, it's very easy also, and it's important also, because you need to know this thing. Okay, so next thing is that this physical quantity is converted into two types. That is, one is this fundamental physical quantity, another is derived physical quantity, which was written also there also. So the definition I'm just telling, fundamental physical quantity is what? Quantities which are independent of all other quantities. That is fundamental physical quantity. So that is mass, time, and length. These all the quantities are, and there are 7 this fundamental quantities are 7, and also it is written in the book also. I'll also read that thing also. Okay, next thing is that derived physical quantity. So what is this derived physical quantity? Derived physical quantity is nothing but it can be derived by suitable multiplication or division of different powers of fundamental physical quantity. That's the thing. So I'm telling it again. It can be derived by suitable multiplication or division of different powers of fundamental physical quantity. That's the thing. So we can derive it. That's the thing. Okay, next is for example, like for example, it can be acceleration, it can be speed. So these quantities are actually derived from these base quantities or physical quantities, sorry, or the fundamental quantities. That's the thing. Okay, next let's go to the what are written here. Yeah, next is SI units. So the international system of units, this is known as SI units. In earlier time, I think this we are reading since we were born, I think. Okay, because it's really easy. Okay, so the first thing is that in earlier times, scientists of different countries were using different systems of units for measurement. Three such systems, the CGS, the FPS or British system, and the MKS system, were in use extensively till recently. Okay, so the now SI units which you are looking for, that is, see, one system. So three such systems which are used are CGS, another is FPS, this is the British system, and this is MKS. Okay, now I'll show you what these are. These are actually here it is written. Okay, this thing, in CGS system there were centimeter, gram, and second respectively, which is C means centimeter, gram means G means gram, and then S means second. Then FPS is foot, pound, and second, and here MKS means meter, kilogram, and second. That's it. So the system of units which is at present internationally accepted for measurement is the Système Internationale des Units, French for international system of units. This is the thing. Oh, okay. So this is the thing you need to remember, that it is Système Internationale des Units. This is the actually which is this is the French. Okay, this is the French for international system of units. That's the thing, and for that reason we are telling it SI. Okay, next is the SI with standard scheme of symbols, units, and abbreviations, was developed and recommended by General Conference on Weights and Measures in 1971. This is the thing. For international uses of in scientific, technical, industrial, and commercial work. Because SI units used decimal system, conversions with the system are quite simple and convenient. I think you can understand these things because it's very simple. Also, I'll explain you later also. Now we shall follow the SI units in this book. Now see, here it is written that the SI, there are 7 base units as given in table 2.1. So this is the table, and I was talking about this only. This is the fundamental, also this is the fundamental physical quantities, also it is known as SI units. The 7 base units these are. Okay, so now we'll also know it's SI units. So these are actually, and here it is written that this is what, this is radian. Okay, oh yeah, so this is radian and this is teradian. Okay, now actually there are something that it is actually dimensional quantities. Here also it is written that these are dimensional quantities, and these dimensions you can understand it clearly after you will learn this dimension, which is written in the next part of the chapter. Now I can also tell this thing that a physical quantity can be dimensionless, but it can have unit. Okay, that's the thing. So you need to note this point also, it's very important. It can also come as questions, which is a physical quantity can be dimensionless, but it can have units. Okay, this is the thing. Like for example, this angle. Okay, this angle, this one, it is what is this? This is a dimensionless quantity, but it has a unit. But it has a unit, which is this radian. Okay, nothing is showing here. Yes, so this is this radian, this is the unit. Okay, and another, and also we can write it as, here it is also written theta equals to S by R. Okay, that's the thing. And steradian, what is this? Solid angle. Okay, the steradian is the solid angle, and this is also dimensionless, but it also has, but it has unit. Okay, that's the thing. That is only explained here, and this is actually important. We need to just it's very simple, and also it is important. Okay, so you need to keep in your mind this thing. Next is the base quantities. Let's move on to that. So what is that? So base 7 base quantities are there: length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. So here everything is written clearly, and this was also, I've taught this thing before also, the next before this chemistry also, some basic concepts of chemistry. There also the same thing was there, and you can also see that video. Here only I'm just telling you these things, that these are the SI units of such of these quantities. Okay, this meter, length is meter, mass is kilogram, time is seconds, electric current is ampere, thermodynamic temperature is Kelvin, and amount of substance is mole, and luminous intensity is candela. That's it. Okay, next. Yeah, so that's it. Next is here some units written for general use, though outside SI. So these you need to keep in your mind, because actually this is important. Why? Because these are the units which are actually in general use, apart from those units of SI. Okay, this is what minutes, hours, day, year, degree. So these are the things, and here are the measurements also. So here nothing to explain, you just need to keep in your mind these things. Okay, next is note that when mole is used, the elementary entities must be specified. These entities may be atoms, molecules, ions, electrons, other particles, or specified groups of such particles. We employ units for some physical quantities that can be derived from the base 7 base units. Some derived units in terms of the SI base units are given in appendix. So these things you can also see, go there and see this appendix, because it's also, it can improve your this quality of education, because it's actually important. It can improve your knowledge also. This is the thing. Next, so I'm not going to see these things because it's not so important, but it will improve your uh, this knowledge. Okay, that's the thing. Next, measurement of length. You are already familiar with some direct methods for the measurement of length. For example, a meter scale is used for lengths from 10 to the power minus 3 meter to 10 to the power 2 meter. A vernier calipers is used for lengths to an accuracy of 10 to the power minus 4 meters. A screw gauge, I think you should keep these all in mind because this is actually also important, these things. And these are basically used in practicals, and also questions can come, so don't ignore it. Okay, so these are what the vernier caliper, how much we can measure its length, up to which accuracy, these things. Like a screw gauge and a sperometer can be used to measure lengths as less as to 10 to the power minus 5 meter. So its maximum capacity, that is less to 10 to the power minus 5. Okay, these are the negative sides. To measure lengths beyond these ranges, we make use of some special indirect methods. So here also written these things. So we you used to do some indirect methods, that's it. Next is measurement of large distances. So how we measure these large distances? By what? Large distances such as the distance of a planet or a star from the earth, it's really large. Okay, so cannot be measured directly with a meter scale. An important method in such cases is the parallax method. Okay, this is that parallax method. I can explain you this thing. Okay, just wait, see this thing. When you hold a pencil in front of you against some, this is one practical which is, it is showing how we measure this parallax method. I'm just reading it just carefully, you can also do with me, along with me, this thing. When you hold a pencil, so hold a pencil in front of you against some specific point on the background of wall, so it can be a wall. Okay, and look at the pencil first through your left eye. Okay, look at it through your left eye, A, and closing the right eye, and then look at the pencil through your right eye, B. Closing the left eye, you would notice that the position of the pencil seems to change with respect to the point on the wall. This is the thing actually. I think this is the parallax. Okay, I think you have done this thing since childhood, because we used to see this thing that when closing our eyes, I don't know about you, but I used to do it every time when I was a child, and it was so funny also. I mean, like we're doing something like left eye closing, then right eye, and then like that. Okay, this is very interesting also. Next, so the distance between the 2 points of the observation is called the basis in this example. So this is actually science. That time we didn't know that what is this actually happening when I when I'm looking like this from this left eye, this is something else is happening. When we're looking from this right eye, something else is happening. So that's the thing. So this is also science. Okay, this thing you need to know. So the distance between the 2 points of observation is called the basis. This is the thing. And in this example, the basis is the distance between the eyes. To measure the distance d of a far away planet S by the parallax method, we observe it from two different positions, A and B, on the earth, separated by distance AB equals to B at the same time, as shown in figure 2.2. So there is a figure also. Here it is. This is the parallax method. So you can also see this. It's not so important, but you just need to know this. And actually we have this parallax errors. Okay, when you'll do practical, or if you have done also, then in the light experiment of the lenses or the mirror experiment, so there are these parallax error is there, where we can avoid parallax. For that reason we used to write in the precautions. Okay, so these things are not so important, but it's important in the practical life. Okay, so parallatic angle, this is known as, this ASB is known as parallatic angle. And as the planet is very far away, B by D is very 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 less than 1. That's the thing. Therefore theta is very small. So then we approximately take AB as an arc of length B of a circle. I don't think you will understand like this by telling you, and if those who are interested, just do this on a paper and you can understand it, because it's very simple, not so hard. Okay, and it's not so important. For that reason I'm not telling you these things. Okay, next are what here are some examples given, so do practice these examples because it's important, and we need to get through all the concepts by this only. Okay, next is estimation of very small distances, size of a molecule. So this is very small. We know how small is a molecule, and the size of a molecule we need to get. Okay, so to measure a very small size like that of a molecule, which is 10 to the power minus 8 meters to 10 to the power minus 10 meters, we have to adopt special methods. We cannot use a screw gauge or similar instruments. Even a microscope has certain limitations. An optical microscope uses visible light to look at the system under investigations. As light as wave like features, the resolution to which an optical microscope can be used is the wavelength of light. A detailed explanation can be found in class 12 physics textbook. Okay, and for visible light, the range of wavelengths is from about 4000 Armstrong to 7000 Armstrongs, which is 1 Armstrong equal to 1 uh, equals to 10 to the power minus 10 meters. So these are the thing which is written. This is actually you can understand this in class 12. Okay, so here see a simple method for estimating the molecular size of oleic acid is given below. Like oleic acid is a soapy liquid with large molecular size of the order of 10 to the power minus 9 meters. The idea is to first form monomolecular layer of oleic acid. So okay, I think you should, if you have interest in this, then you should you can also read these things just once and do this example. You can get everything. Okay, next I'm going to range of lengths. I don't think it's really important, but still I'm reading this thing. Okay, the most important thing is the next later part of the chapter, that is here. This is this errors, then dimensions, dimensional analysis will come. So these are important, but here this is less important, but still we should learn, we should read these things once. Okay, the sizes of the objects we come across in the universe vary over a very wide range. These may vary from the size of the order of 10 to the power minus 14 meter of the tiny nucleus of an atom to the size of the order of 10 to the power 26 meters of the extent of the observable universe. So table 2.3 gives the range of the order and order of lengths and sizes of some these objects. Okay, this one. See, this is important. Yeah, this part where tables are important, tables were given, these are important actually, because the questions can come directly like this, or what is the size of proton, and we have to answer it is 10 to the power minus 15. Okay, in length in meters. Okay, so these are all given here. Distance of the moon, distance of the earth, distance of the sun from the earth. Okay, that's the thing. Oh, sorry. Yeah, radius of the earth. Okay, and distance of the moon from the earth. That's the thing. Next, distance of Andromeda galaxy, so which is 10 to the power 22 meters. So these all are given here. And okay, next is here also given. So this one, this also important. Another thing, this is, these are the here measurements are given, that is 1 Fermi equals to 1 F equals to, which is known as 1 F equals to 10 to the power minus 15 meter, then 1 angstrom equals to 10 to the power minus 10 meters, 1 astronomical unit, which is AU, that is average distance of the sun from the earth, that is equal to 1.496 into 10 to the power 11 meters. Okay, Next, 1 light year equals to 9.46 into 10 to the power 15 meters, which is the distance that light travels with velocity of 3 into 10 to the power 8 meter per second in 1 year. And 1 parsec, that's the last one, 3.08 into 10 to the power 16 meters. Okay, these are actually important. Next part is measurement of mass. So here it is written that the prototypes of the international standard kilogram supplied of by the International Bureau of Weights and Measures, this is BIPM. This thing you should remember, because actually it is in your NCRE textbook, and it can come in the exams. Okay, are available in many other laboratories of different countries. This is available at National Physical Laboratory in NPL in New Delhi. Okay, next is here another thing is important, that here this one U. While dealing with atoms and molecules, the kilogram is an inconvenient unit. So before, actually, we used to write it AMU, atomic mass unit. Now we are writing it unified atomic mass unit, which is U. And these things I have explained better, this carbon 12 and these things I've explained better in the chemistry, some basic concepts of chemistry, the first chapter of 11th standard. And it's very important chapter also, that is also like a base unit, a base chapter for next chapters of chemistry. Okay, so actually you should also learn that chapter completely nicely, and that's also important. So if you can visit that video, that is also good. Okay, so these all are I have explained there, so I'm not explaining here again. Okay, next is range of masses. Here also same thing are given, not so important, but here this thing is important, where there will be a table in this NCRD, that is actually important. What this is, see, the mass of electron equals to 10 to the power minus 30 kg. These things are actually important. See, sun, the mass of sun is 10 to the power 30 kg, but the mass of electron is 10 to the power minus 30 kg. Okay, that's the thing. And next, let's go to measurement of time. So I think you know this thing, but still, if you have any doubt, you can go through this. This is not so important, but it will increase your knowledge, which is important. And so let's move on to the main part of the chapter, that is accuracy, precision. So I'm not wasting more your times, so most of the students might not be interested in these all things. For that only I'm going to errors, and also it's not so important, for the reason I'm not paying such attention to these. So you can read yourself. I've just told what all are important through these. If you have a lot of time, you can read these. Okay. Next is accuracy, precision of instruments, and errors in measurement. Okay. Let's move on to this. So first, I'm reading this once, then I'll show you all the formulas and all. Okay. Okay. So let's start this. Measurement is the foundation of all experimental science and technology. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is called error. Every calculated quantity which is based on measured values also has an error. We shall distinguish between two terms. Okay, one is accuracy and one is precision. So the accuracy of the measurement is a measure of how close the measured value is to the true value of the quantity. Now precision tells us to what resolution or limit the quantity is measured. The accuracy in the measurement may depend on several factors, including the limit of the resolution of the measuring instrument. And for example, suppose so here one example is also given, like suppose the true value of a certain length is near, it's like 3.678 centimeters in one experiment using a measuring instrument of resolution 0.1 centimeter. So I don't think some people might not be understanding this thing. Okay, just wait, I'm just reading it once, then I'll explain you everything. Okay, Next is measured value is found to be 3.5 centimeter. While in another experiment, using the measuring device of greater resolution, say 0.01 centimeters, the length is determined to be 3.38. The first measurement has more accuracy because it's, see this thing, okay, because it is what, because it is closer to the true value but less precision. Its resolution is only 0.1 centimeter. So here it is given everything, and this table also, another table come that what is the range and order. Actually this is this time, this table, okay, this is also important. You need to understand this table. Okay, if you are not interested in reading that what is the measure, how to measure time, but just read, just remember this table, okay, and nothing else from the previous things. Next let's go to here that errors, thus every measurement is approximate due to errors in measurement. In general, the errors in measurement can be broadly classified as systematic errors and random errors. Okay, so there are actually broad classification. We can tell it as systematic errors, and then systematic errors as instrumental errors, personal errors, and another is imperfection in experimental technique to, or procedure. Then random error is also there. Random errors are what, here see, random errors are also there. There is least count error, that is also there. So let me what I'll do, okay, let me explain these things, because yeah, you need good explanation, okay, of what all we have read. I think some have understood, some have not understood, so let me tell these all. Okay, so first thing, what is error? First doubt, what is error? Okay, we know error is what, error is something like which any error, it can be any error, okay, but what's the exact definition, or what we understand as physics, what is understood as error in physics, that we need to understand, okay. So it is what, it is the difference of true value and measured value. That's the thing, it's the difference between true value, it's not working, just a minute. Okay, I'm writing here, it's a difference between oh yeah, so it's a difference between true value and the measured value. That's it. Okay, you just write along with me, you can understand. Okay, so it's a difference between true value and the measured value. That's what we understand by errors in physics. Next, errors are broadly classified into systematic errors. One is systematic errors, and another is random error. So what's the basic difference between these two? I will explain now. So systematic error means it actually always appear in one side of actual value. Okay, this error always appear in one side of the actual value. For example, like we can tell it as this zero error. Okay, if you don't know about the zero error, you will also learn this thing in the practicals. Okay, zero error is there where the instrument only is there for errors. And random error, yeah. So what is random error? It may appear in both the sides of actual value. Okay, it may appear in the both the sides, so this error can occur from anywhere. We don't know how it came and what happened to it, but it can happen. Like the least count error, that is also there. So these are the things. So these are only important here. And now let's read little bit from the text. Now then I'll explain you about the absolute errors and such thing. Okay, so next is systematic errors. The systematic errors are those errors that tend to be in one direction, either positive or negative. Some of the sources of systematic errors are instrumental errors that arise from the errors due to imperfect design or calibration of the measuring instrument. So here also it is given this zero error in the instrument, etc. For example, the temperature gradations of a thermometer may be inadequately calibrated. It may read 104 degrees Celsius at the boiling point of water at STB, whereas it should read 100 degrees Celsius. So the instrument only it has the error. Okay, so it should read 100 degrees Celsius, as we know that boiling of point of water is 100 degrees Celsius. So water, but it is showing 104. So for that reason only, anything, any quantity which you are looking at it, suppose anything which like suppose 30 degrees Celsius, one object is showing 30 degrees Celsius, then we have to do that, we should subtract it by -4. That's it, we should do it -4. Then what will happen? Then we can get the correct value, otherwise there will be wrong. So this is the thing. Next, in a vernier caliper, the zero mark of the vernier caliper may not coincide with the zero mark of the main scale, or simply an ordinary meter scale may be one off at one end. So these are the things. Next, imperfection in experimental technique or procedure. To determine the temperature of a human body, a thermometer placed under the armpit will always give a temperature lower than the actual value of the body temperature. Other external conditions such as the changes in temperature, humidity, wind, velocity, etc. during the experiment may systematically affect the instrument of the affect the measurement. That's the thing. Next is personal errors that arise due to an individual bias, lack of proper setting of the apparatus, or individual's carelessness in taking observations without observing proper precautions, etc. So this is all happened actually. Next, for example, if you by a habit always hold your head a bit too far to the right while reading the position of the needle on the scale, you will introduce an error due to parallax. I told you before also that when you will do these optics or these lanes, these optics experiments, you can know these things. Okay. The next thing is systematic errors can be minimized by improving experimental techniques, selecting better instruments, and removing personal bias as far as possible. For a given setup, these errors may be estimated as to a certain this extent, and the necessary corrections may be applied to the readings. Now let's go to random errors. The random errors are those errors which occur irregularly and hence are random with respect to sign and size. So these can arise due to random and unpredictable fluctuation in experimental conditions. For example, unpredictable fluctuation in temperature, voltage supply, and mechanical vibrations of experimental setup. So these are the things only. Okay. Next is least count error. So what is this? The smallest value that can be measured by the measuring instrument is called its least count. All the readings or measured values are good only up to this value. The least count error is the error associated with the resolution of the instrument. So how we are understanding this thing? And then for example, a vernier caliper has the least count as 0.01 centimeter. A speedometer may have a least count of 0.0001 centimeter. That's it. The least count or error belongs to the category of random errors, but within a limited size. It occurs with both systematic and random errors. If we use a meter scale for measurement of length, it may have graduations at 1 mm division scale, spacing, or interval. Using instruments of higher precision, improving experimental techniques, etc., we can reduce the least count error. Okay, these are the things. Next, let's go to absolute error. So I don't think you will understand anything from here, because also so this thing, let me read this definition. The magnitude of the difference between the individual measurement and the true value of the quantity is called the absolute error of the measurement. So I know that most of the people will not get what I'm reading, Okay, I will completely explain this thing. So these all are written here. I'll explain this. Okay, let me go to this here. Yes. So what is absolute error? Okay. So let us consider that we're taking some readings. Okay. Okay, let me write in this green color. Suppose R1, R2, R3. These are some readings which I have taken. R4 and dot 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 Rn. Okay. Next, what happened? Okay, I'm taking these four values. Okay, for better understanding. Now we need to get its average. Okay, what is the readings which I'm taking? We need to get its average or the mean value. What is that? That is R1 plus R2 plus R3 plus R4. Okay, then we will divide it by 4. Okay, this is divided by 4. So next what we'll do now, okay, let me shorten this. Yes, next what we'll do, we'll get it that r mean equals to r mean, this is the r mean, this is the average, this is the average. Okay, average. And also I'm taking it as rm. Okay, rm. So this value which we got, this is the true value because it's the average. So this is the actual or the true value. Okay, this is the true value. So we got it. What is the true value? Next thing. Okay, next thing we'll do. Oh, next is that when we considered that what is the error which has occurred, we need to find the difference between them. So what's the difference? Now we need to represent this as delta r1, suppose in this. Okay, here this delta r1, what is happening? What will happen is that rm, which is the true value, minus r1. And also one thing you need to note that it can be plus or minus. Okay, the error can be plus or also it can be minus. That's the thing. And we got it. That's it only. I hope you have understood this thing. And we can find it of suppose r2. Okay, this can be also rm plus minus r2. That's it. Okay, now let's learn the representation, how we will represent this thing. Okay, so we can represent it very easy. That's also, that is what, that is delta rn equals to rm plus minus rn. Also we can represent the main representation. This is the definition that or the formula you can tell. This is only known as absolute error. Okay, if there is a question to find the absolute error, then you can find in this way. Okay, in this method which I've showed you. Now the representation is that delta x equals to x, this bar, plus minus x. That's it. Okay, this means this is the average one. Okay, here there is a top, there is a bar, it means it's the average. Okay, that's it. I hope it's clear. And okay, next what is given here, the arithmetic mean final or mean absolute error. Now let's go to the mean absolute error. So here also like that it is explained that you will not understand. Most people don't understand this. Okay, now also this one also I'll make you understand. So what is the mean absolute error? So we need to get an mean of these all errors. Okay, so we have got the absolute error. Okay, this is the absolute error that we got, absolute error. Now let's get the mean of those. Mean of those will be the mean absolute error. Okay, so how we can solve it? It's very easy, it's really easy, just believe me. See what I'm doing. Now let's get this delta r average. Oh, so delta r average. Okay, so what's this is equal to delta r1, and we need to give mod. because mod is very important. We cannot subtract it because sometime answer also comes as 0. So that will be a great blunder. Okay, plus delta r2. Okay, mod again. Like this we will divide it, like plus delta r and whatever. So here I am showing the example, so I'll do like this, that r1 plus r2 delta r2, so by divided by 2, or the any number. Okay, that's the thing, number of the digits. So we got it, this thing. So the number of there are two errors, the two absolute errors, so I'm dividing it by 2. I hope you know this thing, that what is average. And let's learn the representation. It's really easy, because just find the average. Suppose there is a question which is telling us that find the mean absolute error of this values. So it's very easy, just do like this, just find the average, just find the mean, just find the absolute errors, then find the mean, or do the average of those absolute errors. That's it, and you will get the answer. It's very simple. Okay, I hope you have understood this thing. Now let's learn the representation, how to represent it. Representation is also very easy. It's just rm plus minus delta r average, and means this is the formula. Now the representation is that x bar plus minus delta x bar. Okay, that's it. Very simple. Now the next is that relative error, or the percentage error also there. This is also very simple, and I'm showing here only because some will not understand from book. Same thing. Okay, so the next thing is that relative error. So what is a relative error? Relative error, relative error is very easy. It's just the mean absolute error divided by the mean value. That's it. It's really very easy. Okay, so this is the thing. Actually nothing is complicated, everything is easy here. Okay, that's it. So we have written this. Next, also we can tell it that delta add average divided by our mean. Okay, the mean which we got that time, only the mean value. The first time we have got the average true value, which from which we got the true value, that's only rm. Next is representation. So we represent it as delta x bar divided by x bar. That's it. Okay, next is percentage error. Percentage error is also very simple. Everything is simple here. Okay, what's percentage error? Percentage error, this is also simple. Why? We just need to find the relative error multiplied by 100, that we can get the percentage. So percentage means something 100. Okay, so that is only here, we got it. So that is what relative error. Relative error means r average divided by rm, or the mean, into 100. That's it, and we got the value. That's it. And now let's learn the representation. The representation here is a bit different. So that is just x bar plus minus percentage error, like this. Okay, we need to represent it like this. Now I can also give one example. See, like 6 plus minus 10%. Okay, this is like this only, we need to represent it. I hope everything is clear now. Now we'll learn here are some examples. You can just try it out because it's very easy. Next, nothing else is here important. Okay, Now I'll show you. Actually, here, actually, one important is there, that is the combination of errors, where we need to find the sum, difference, products. Okay, so this is the main thing which will make you. Okay, see here, one rule is also given, so everything. Okay, I'll explain you everything now. So actually the questions always used to come from, most of the questions come from this multiplication, division, and not many comes from this addition or subtraction. So addition and subtraction, that is just this. Okay, I'll show you this also. So this addition, subtraction, or the multiplication or the division, these all are known as propagation of error. Okay, so let's learn the propagation of error. So the first one is addition or subtraction. Okay, the error should always be added. This thing is the main rule of this addition or subtraction, that error should always be added. It cannot be subtracted. Why? Suppose there is a subtraction question, but it cannot be subtracted. Why? Because error always sum up, and it got वो कभी भी घटता नहीं है. It always used to get more and more. Okay, that's the thing. Now for that reason, for example, I'm giving one example here. Suppose here are volumes are given. Volumes of two cubes are given here, and that is 2 centimeter whole cube plus minus 0.02, and another is 4 centimeter cube plus minus 0.04. Okay. Oh. Yeah, 0.04. Okay, so how we will solve this thing? This is very easy and it's very interesting also. How we'll solve it? Okay, let's go for first the addition. So when we add it, what we used to do is that we just get this 2, which is 2 plus 4. First is 6 centimeters cube plus minus, then we need to add these two also. 0.02 plus 0.04, which is 0.06. That's it. And we got the answer. Next is subtraction. Subtraction also very simple. We just need to subtract this 2, which is see here 4 minus 2 we need to do. We cannot get a negative one. Okay, so this is means if negative answer will come, then nothing, but we used to do when we were kids, like that only we need to get. That is 4 minus 2, which is 2 centimeters, 2 centimeter cube plus minus 0.06. That's it, and we got the answer. I hope you have written everything. I'm erasing it. Okay, I hope it's clear. Now let's go to the complicated part, but it's not so complicated. Some students think it's complicated, but it's not. Okay, that's very easy. If you understand once, it will be very easy. Okay, the first one is multiplication. I'm going to teach the multiplication first. So what is this multiplication? How we can solve it? Means in this error. So suppose one formula is given, that A equals to L into B. Or the area, I think you know it, the area of a rectangle, that's a length into breadth. Okay, that's it. So how we can represent it? So if we learn the representation, you can understand this thing. So this will be delta A by A equals to delta L by L plus delta B by B. That's it. Very simple. Also, if there will be power, I will teach in the next thing, that is the division. So the division part is also very simple. Division. Okay, so division is, suppose there is something which is there, y equals to A by B. So how we will represent this thing? Division also same thing will happen. It will be like delta y by y equals to delta A by A plus delta B by B. That's it. Okay, I hope it's clear. Next is one this is important actually. When powers will come, what will do, or the exponents. Okay, so the thing which is like, the question is y equals to a square. Okay, let me do the representation, or let's solve the question only. Okay, a square bq by c4. So let's solve it. How we can represent it? It's very simple. It's just that delta y divided by y equals to, see, when this will be square, the exponent will come here and it will be multiplied. 2 into delta a by a plus 3 into delta b by b plus 4 into delta c by c. Oh, you're not, no spaces there. Okay, so you understand that delta c by c. Okay, that's it. So let's solve a question here. Okay, because when I want to solve a question, so that you will be clearer here. Okay, so the question is that okay, let me solve the percentage error. Okay, I hope this is actually, you can solve this thing. So let me show you one percentage error question, okay, which is actually important, and also most of the students don't understand this thing. This is very easy. Okay, first I'll show you the representation, then I'll do the question. Okay, so what is that? Percentage error in z. We need to find the percentage error in z. So with this question, I will make you understand how to do it. Okay, z equals to xa yb divided by vc. Okay, and the question also, something else will be written also there, that this is that x is equal to we need to solve it. We need to get that percentage error in z, where x equals to x plus minus delta x, then y equals to y plus minus delta y, and v equals to v plus minus delta v. That's it. So these are all the question. Now let's solve it. How will we solve it? It's also very simple. Just in the way of division, we'll also do like that, the same thing. This will be what? This will be delta z. Only the difference is that we'll multiply it with 100. Okay, delta z by z into 100 equals to a into this. See, this is the exponent, we brought it here. A into percentage error in x. Okay, plus, so here is no space, for that I'm doing like this, but don't write it like this. Okay, then b, percentage error in y, and similarly plus, we'll do that here. Okay, let me do like this. Wait just a minute. Yes, so I'm solving it directly because here is no space. So it will be like delta z divided by z into 100 equals to a into delta x by x into 100. Okay, next plus b into delta y by y into 100, then plus c into delta v by v into 100. Okay, that's it. Very simple. I hope you have understood these all, and just write with me, otherwise you will not understand, because here is actually no space for that. The handwriting also turning into very bad. That's the thing. So next, let's go to okay, let's solve a question. Okay, are you interested in solving a question? Actually, it's important, so let's solve it. Otherwise you will not get how question come. Okay, that's the thing. So question looks very difficult, but actually when we'll solve it, it will be very easy. What's the question? It is that z equals to x to the power 3 y to the power 2 divided by p to the power 3 by 2. That's it. This is the question. Then how to solve it? And what's the question? Let me tell you what's the question. Percentage error in x equals to 2%. Okay, let me short this question, otherwise there is no space. Okay, so percentage error in x is, just write it, percentage error in x. Okay, x 2%, that's the percentage error. Okay, next y is 0.5%, and this z, sorry, this is p equals to 4%. That's it. Now let's find the percentage error in z. So that's the question. So what is the percentage error in z? We need to find this thing. Let me short it again, then I'll solve it. Okay, so it's very simple. First thing, procedure you need to do is that delta z by z into 100, it is equals to 3 into, now see, yeah, why I'm doing here 3, because it's an exponent, that's a 3. We need to bring it over to multiply. So 3 into 2% plus 2 into 0.5% plus 3 by 2 into 4%, and we need to solve this. What will be the value? Can you tell it? 3 into 2 6% plus this 0.5 into 2, which is 1, plus this 2 will get cancelled, and then it will be also 6. So the percentage error of this in z equals to 6 plus 6, 12 plus 13. That's it, 13%. Very simple. I think when you have seen this question, it seemed very difficult, but it's actually not. Okay, that's it. And you should also solve some questions in the examples. Also, there are a lot of questions given. You should solve it. Okay, so I have taught everything, this product or question, everything is completed now. Now let's go to where? Now let's go to significant figures, and these all are just, see what is here written. Hence the rule: the relative error in the physical quantity raised to the power k is the k times the relative error in the individual quantity. So this is actually here they have solved, and they are explaining this thing. So just read once these things. Also, I have given my examples, you do your examples, then it will be completely clear. Now let's go to another important part of this chapter, which is significant figures. So as discussed above, every measurement involves this errors. Thus the result of measurement should be reported in a way that indicates the precision of measurement. Normally the reported result of the measurement is a number that includes all digits in the number that are known reliably plus the first digit that is uncertain. The reliable digits plus the first uncertain digit are known as significant digits or significant figures. So here also I want to explain you this thing, that this thing also I have clearly explained in the first chapter of chemistry 11th, some basic concepts of chemistry. I have explained it very clearly, all the important rules I've explained there, everything I've explained there. So please go and follow, please and watch that thing and follow the instructions what I've given there. Okay, so you can do that thing, because I don't want to waste my time and your time also. Okay, so explaining the same thing again and again, if anybody have watched that video, so he or she will be bored. So for that reason I'm doing this thing. Okay, so significant figures I have completely nicely explained that thing. So all the this all things like rounding off also I have explained, okay, there. So please follow there, please watch it and follow everything that what I've told. Okay, nothing is different here, everything is similar. Okay, And this rounding off also I have done there. How, what are the rules and how to do that. Questions also I have given some. So please go and check that video. Next is rules for determining the uncertainty in the results. So these are also what, so these are some rules. Okay, I'll tell you these things. Rounding up the uncertain digits, this I have done, that how to do these insignificant like 5 and these things. Okay, now let's go to here, that rules for determining the uncertainty in the results of arithmetic calculations. So the rules, this is what, this is different from chemistry, what I taught in chemistry. For that reason I'm teaching this thing. Okay, the rules for determining the uncertainty or error in the number or measured quantity in the arithmetic operations can be understood from the following examples. If the length and the breadth of a thin rectangular sheet are measured using a meter, using a meter scale as 16.2 centimeter and 10.1 centimeter respectively, there are three significant figures in each measurement. It means that the length L may be written as L equals to 16.2 plus minus 0.1 centimeter. Also it can be written as 16.2 centimeters plus minus 0.6 percentage. Okay, that's the thing. So similarly the breadth can be also written in the same way. It's very simple, nothing complicated here. Next is, if a set of experimental data is specified to n significant figures, a result obtained by combining the data will also be valid to n significant figures. However, if data are subtracted, the number of significant figures can be reduced. This can also happen. So this thing, just read once, okay, everything. Like for example, so I'm not explaining these examples because if you will read these, you can only understand this thing. I'm just telling the important points. Okay, the relative error of a value of number specified to significant figures depends on only on n, not only on n, but also on the number itself. That's it. This is all about the errors and how to do it with the significant. Okay, next, finally remember that intermediate results in a multi-step computation should be calculated to one more significant figure in every measurement than the number of digits in the least precise measurement. So actually whatever you're reading here, you just need to follow these things, because when you're doing any multiplication, calculation, anything which you're doing in this whole chapter, from this whole chapter also, you need to follow this, the later chapters also. But this chapter is very important. When you're solving anything, just keep in your mind that what is the most accurate and how to do these significant numbers and how to manage, how to round off and everything. This, okay, everything I explained in that some basic concepts of chemistry, the first chapter, first 11th chapter, 11th class, first chapter, there only I've explained. So please check out that video. Okay, next is dimensions. So dimension, and this here we are coming to the end of the chapter. Okay, it's, and this is a very important topic, and most of the thing are that you need to keep in your mind. So this dimension analysis, so what is this exactly? So here are a lot of stuffs which are written here, and the important part I'm telling you, because everything is not important in Ncert. Okay, everything is not important. Okay, so the first thing is that the simple principle, this principle of homogeneity of dimensions. So I'll tell you everything in short. Okay, these things. Okay, and what are all else are there, just I'm looking at once. Okay, let me tell this thing. So what is a dimension? What we mean by dimension, nothing else is there, huh? Yeah, another thing is written here, just the bold thing I'm just focusing, then I'll explain you everything. Okay, if an equation fails this consistency test, it is proved wrong, but if it passes, it is not proved right. Thus a dimensionally correct equation need not be actually an exact correct equation, but dimensionally a wrong, incorrect, or inconsistent equation must be wrong. So these are some principles which I'll also teach you later. Okay, that's it. That is only given in the book, in your book, and everything here is not so important. You just follow what I'm telling, because just let me explain everything to you about this dimension. I'll just please trust me, I'll explain you everything, and then read these things. Okay, read these things by your own, because this is not so important. Means what is written, if you'll read now, if I'll make you read now, you will not understand anything. So let me first explain this thing, then you will understand this, then you will feel it that it's important. Okay, that's what I want to tell you. Now the first thing is that dimension. So what is a dimension? Okay, now I'm just telling the this. Oh, so how it is happening? Okay, let me write it again. Okay, so dimension. So what is a dimension? What we mean by that? What is a dimension? I think a lot of have your questions. So it's very easy. It is just the powers to which fundamental quantities must be raised in order to express the given physical quantity are called its dimension. Just note down this definition. It will be very easy for you to get through all these topics. Okay, all the whole topics. Okay. So the first thing is that the powers to which, again I'm telling this definition, the powers to which fundamental quantities must be raised in order to express the given physical quantity are called its dimension. That's it. So let's take the example of area, but it should be fundamental quantities or the base quantities. Okay, that's it. So the first thing is that let's take the example of area. Area is, you know that it's length into length. See, the what we're taking is that as a length into breadth, but what's the breadth? It is the length only. So for the reason we're taking it L square. Okay, that's it. Area of anything, A square also it has, but when we are taking this, we are taking it L square. And how we need to represent it, I'll show you now only. So the main work of dimension is to represent how everything. Now let's okay, let me explain you this one. We used to express it with the 7 fundamental quantities only. Okay, the most used are MLT, or the mass, L which is length, and T which is time. That's it. So M, L, T. So this example that where we did the dimension of area, that is L square, how we need to represent here? We need to represent that this is M is 0, L is 2, and T is 0. This is the thing. Like this only we can explain it. It's really very easy. Okay, and please remember all the dimensional quantities of every, like force has M1, L1, T minus 2. That's it. Very easy. And some similar I'm telling, just listen to me clearly and you can note everything. You can know the first one I'm explaining you is that M0, L0, and T to the power 0. Okay, what happens where it doesn't have any dimension? These are the dimensionless quantities. What are these? It is strain, refractive index, relative density, angle, solid angle, distance gradient, relative permittivity, which is the dilatory constant, and relative permeability. That's it, and etc. and more are also there. Okay, but these are important. Okay, next another example I'm giving you. But these you need to just remember. When I'll just I can like make you, you need to get all through the list of dimensions which are the important, which everything which you come across in your 11th and 12th standard, all the units, all these quantities, you need to get the dimensions of this, because this will only help you with the preceding chapter. Now I can tell you everything like the frequency, angular frequency, this velocity gradient, but you cannot understand anything. Okay, that's the thing. So you need to just make a list of what you're coming across. Suppose next chapter is like, and suppose this laws of is work, energy, power, every chapter which you are coming through, like electricity chapter. So everything you need to make it your own, you need to make your own notes, and then you need to read it. Okay, the next principle of homogeneity that we were looking there, that is nothing but actually I've not told you that thing, right? Okay, fine. Next is application of dimensional analysis. Now I'm going to tell you. So have you remember the thing that I've told you, that physical quantity from one system to another is what it is? I've told you that it is there is a formula which it says that n1 equals to u1 equals to n2 u2 equals to constant. I've told this formula. Okay. This is what this is one thing which will help us to find through all the applications of dimensional analysis. The first one is to convert a physical quantity from one system to another. That's the first one. So the first one is to convert a physical quantity from one system to another. So we can convert, like suppose the question is given that something is another, suppose dyne. Okay, let's convert the Newton into dyne. Okay, that's very easy to do with this application. So these are the applications actually. Then second application is that to check the dimensional correctness of a given physical relation, we can also check that thing. And that is also there is a principle of homogeneity which is there, that is just listen nicely. What is that? First point is that only those physical quantity can be added or subtracted which have same dimension. That's the thing. We need to follow that rule and then apply the formulas into that application. Okay, next is in the second application which I'm telling. Okay, the second point is that this is the principle of homogeneity. The dimensions of all the terms written on both the sides of a correct equation should be same. That's the principle of homogeneity which we need to follow in the second application. Next, the third application. And what is the third application? That is as a research tool to derive a new relation. We can also use dimensional analysis as a research tool to derive a new relation. That's the thing. It's very easy. Next, well, I'm just telling you the limitations of dimensional analysis. Just note it down. Okay, I'm just reading it out again. I'm reading it all from my notes. So just clearly just listen to it. Okay. Limitation of dimensional analysis. If dimensions are given, physical quantity may not be unique, as many physical quantities have same dimensions. Okay, like for example I'm telling, if the dimensional formula of a physical quantity is suppose it is m1 l2 l to the power 2 t to the power minus 2. So that can be work, it can also be torque, it can also be energy. So we don't know what it is. That's the thing. A lot of we cannot derive it. Okay. Next is numerical constant. So numerical constant having no dimension, which is like this k, such as like 1 by 2, we don't take it as a dimension. Okay, or pi. Okay, we don't take it as a dimension, cannot be deduced by the methods of dimension, we cannot take it as dimensions. Okay, this is the second rule. Third limitation is that the method of dimension cannot be used to derive relation other than product of power function. Okay, I'll explain you nicely this thing. The third point, that is the method of dimension cannot be used to derive relation other than product of power function. So for example, this thing that S is equal to ut plus half at square. We know this formula. What will happen is that we will not consider only we need to get the means this products. We cannot take the multiplication, means the addition or the subtraction of this. Like this, should be equal to this ut, like this, or a should be equal to this 80 square. Half is not considered. Okay, that's the thing. So, or we can also consider ut should be equal to 80, like that. Next, the last point, that is, if a physical quantity depends on three physical quantities, out of which two have same dimensions, the formula cannot be derived by theory of dimension. That's the thing. Okay, so we cannot derive it by the theory of dimension. So I hope you have understood all these things, and whatever left, please read it once, and please read the summary also. Okay, this is very important. Everything which I have explained, it is here, and you need to read this blue box. Okay, so thank you for your time. So thanks, and please subscribe to this channel so that you can get more videos on NCERT related, and I will teach everything related to NCERT of means from this NCERT book of this chemistry, biology and physics, 11th and 12th standard. Okay, so thank you.